সিগমাটা ফাস্ট আছে কোথায় এটা Welcome to today's class, and today's we discuss about the block 3 linear programming problems and its variant 2, and we cover the unit 7, and the topic is actually goal programming. What is actually a goal programming? In the earlier class you know about the LPP. In LPP we consider the objective function, only one objective function, and number of constants are there, and the conditional equations are there. In LPP, we solve the objective function, that is to maximize or to minimize. Maximize the profit and minimize the cost. But in goal programming, that is different. In goal programming, there are a number of goals, means multiple objectives are there, and we try to find the best optimal solution in goal programming to achieve the target or goals. So today we discuss about the various objectives. After completion of this unit, you should be able to learn what is goal programming, how to formulate the business problem as goal programming, and the methods to solve the goal programming. So you know that the LPP you can solve by using the simplest method or graphical method. Here also in goal programming, we use both the method to solve the goal programming. But the main objective is how to formulate the business problems as goal programming with multiple objectives. So the definition of goal programming is an approach used for solving a multiple objective optimization problems that balance trade-off in conflicting objectives. In general, it is an approach of deriving a best possible satisfactory level of goal attainment. So the goal programming is the approach to solve the multiple objective problems to find the best solution or best optimal solution to achieve the target or satisfactory level of goal attainment. So generally, many various organizations use this goal programming technique because organizations' objectives vary according to the characteristics, types, philosophies of management, particular environment conditions of the organization. There is no single universal goal for the organization. Profit maximization, which is regarded as the sole objective of the business firm in classical economic theory. So in LPP or in goal programming, there is not a single objective, means only profit maximization or cost minimization. But what happened? In goal programming, there are so many other goals to profit the maximization of the organization that may be related to the social responsibility, the relation with the public. Third one is how to achieve the outside relationship or industrial relationship with the other organizations. So these are the different goals for the profit maximization. So in goal programming, we try to solve these problems. Then what is the difference between LPP and GP, goal programming? In linear programming, there is only one goal, that is maximization profit or minimization cost. But in goal programming, there are multiple goals and deviation variables are minimized. So already you know in LPP, there is one objective function and number of constants are there. And the constants may be represented in the less than equal to or greater than equal to, because less than equal to constants means what? Actually, it is inequality. We add some slack variable to equality the constants. If there is greater than equal to symbol in the constants, we subtract the surplus variable to maintain the equality. So similarly here also in goal programming, we consider two other variables, that is not the deviation variables. And the deviation variables are represented by using D1 minus or D1 plus. So later we can explain what is actually deviation variable. Let us consider how to formulate the goal programming. One example I am explaining here. A manufacturing firm produces two types of products, A and B. The unit profit from product A is rupees 100 and that of product B is rupees 50. The goal of farm is to earn a total profit of exactly rupees 700 in the next week. So if you go through this LPP model, if you use the LPP model, we have to write the equation. The objective equation is maximize, that is known as profit, equal to Z equal to 100x1 plus x2. What are x1, x2? x1 and x2 are the number of units of products of A and B respectively. The single goal of profit maximization is stated as maximize Z equal to 100 x1 plus x2. That is the objective function. But since the goal of the farm is to earn a target profit of rupees 700 per week, the profit goal can be restated to allow the underachievement or overachievement. So underachievement means that is known as your deviational variable. One is your underachievement variable, another is your overachievement variable. In LPP, we use these variables. The name is actually slack variable or surplus variable. We can add the surplus variable and slack variable in the constraints for the equality conditions. But here I am writing the equation that is now 100x1 plus x2 plus d1 minus d1 plus equal to 700. So d1 minus is the underachievement and d1 plus is the overachievement. Suppose in a graph, if you draw a line, straight line in a graph in the first quadrant, that is means because as per our condition x1, x2, d1 negative and d1 positive are greater than equal to 0. That means we plot our graph in the first quadrant of the graph paper in x-axis and y-axis. So let us consider if x1, x2, d1 minus and d1 positive or plus are positive, then the straight line we have drawn by using a graph that is known as let us consider A and B. If you draw the straight line, now you consider d1 minus means what? Below the line, and d1 plus means that is above the line. That means these are the persons. So d1 minus means that is the underachievement, and d1 plus means the overachievement. That is d1 plus is called as your surplus variable, and d1 minus is known as your slack variable. Now the goal programming model can be formulated as minimize Z equal to d1 minus plus d1 plus subject to constraints 100x1 plus x2 plus d1 minus plus d1 plus equal to 700, and x1 comma x2 d1 negative and d1 positive is greater than equal to 0. Now the LPP model is converted into the goal programming model. When d1 negative equal to underachievement of the profit goal of rupees 700 and d1 plus is the overachievement of the profit goal rupees 700, then if the profit goal is not completely achieved, these are the conditions. If the profit goal is not completely achieved, the slack in the profit goal will be expressed by a negative deviational, that is known as your underachievement variable d1 negative from the goal, that is below the line. But if the solution shows a profit in excess of rupees 700, the surplus in the profit will be expressed by positive deviational, that is known as your overachievement variable d1 positive from the goal. Similarly, again, if the profit goal of exactly rupees 700 achieved, both d1 negative and d1 positive will be 0. So that means what? All the points on that straight line must be achieved the objective function. In the above example, there are an infinite number of combinations of x1 and x2. That means all the points lying on the straight lines, because only one constraint equations is there that will achieve the profit goal. Therefore, the required solution will be linear combination of x1 and x2 between 2 points, x1 equal to 7, x2 equal to 0, x1 equal to 0, x2 equal to 14. How you get this x1 equal to 7 and x2 equal to 0 and x1 equal to 0 and x2 equal to 14? In the equation, if you put the x1 equal to 0, then you get the x2 value. If you put the x2 equal to 0, then you get the x1 value. So that is now x1 equal to 7 and when x2 equal to 0 and x2 equal to 14 when x1 equal to 0. The straight line we draw, suppose we draw a straight line by using a graph paper. In the first quadrant, it is a straight line, and if I am naming it as AB, the straight line is exactly the isoprofit function line when the total profit is rupees 700, because all the points on the line must satisfy the goal. Similarly, I am explaining another example by considering the example 1. Let us suppose that the manager, in addition to the profit goal of rupees 700, also wants to achieve a sales volume for product A and B close to 5 and 4 respectively. Formulate the problem as a goal programming model. In the previous example, we have one constraint, one target goal, profit. But in the second example, we add another constraint, that means another objectives, that is not to achieve a sales volume for product A and product B, that is close to 5 and 4 respectively. Hence, the model formulated as the constants of the problem can be stated as 100x1 plus x2 equal to 700. Profit target goal, it is dependent on profit target goal. Target means what? We just achieve our goal. Then second constant is x1 less than equal to 5 and x2 less than equal to 4. That is the sales target goal. For this problem, the profit goal and the sales goal are expressed as, that is 100x1 plus x2 plus d1 negative minus d1 positive equal to 700, just like in the example 1. But here the second constant is x1 less than equal to 5. That's why here we add another deviational variable, that is known as d2 negative, d2 minus, that is x1 plus d2 minus equal to 5. And the third constant is x2 plus d3 minus. So x2 plus d3 minus equal to 4. In this way, we write the expressions, goal programming expression, constant equations. This problem can be formulated as the goal programming model as follows. So listen, whenever we write in the LPP, that is the maximize Z, but in your goal programming, always you write that is the minimize Z. What is minimize Z? Z equal to D1 negative plus D1 positive plus D2 negative plus D3 negative. What are the deviational variables we consider in our equation constraints? We write in the minimize in the objective function, that is our objective function. And subject to constraint, 100x1 plus x2 plus d1 minus, that is negative, minus d1 positive equal to 700 as mentioned in the example 1. Now x1 plus d2, that is a deviational variable, x1 plus d2 negative equal to 5. Here we are not considering the d2 positive because the sales targets goals are given in the question, that is maximum possible sales volume. Therefore, d2 plus is not required. So x1 plus d2 negative equal to 5. Similarly, the third constraint equations, x2 plus d3 negative equal to 4. Here also we are not considering D3 positive, D3 plus, because the same situation, the sales target goals are given as the maximum possible sales volume. So D3 plus are not included in the sales target constants. So these are the equation: minimize Z equal to D1 negative minus plus D1 positive, that is a plus, plus D2 minus plus D3 minus, because D2 minus we are using in the third constant equation, and D3 negative used in the third constant equation, and D2 negative is used in the second constant equations. Okay, and the condition is what? X1 comma X2 comma D1 negative comma D1 positive comma D2 negative comma D3 negative greater than equal to 0, means all the values are 0 or in the first quadrant of the graph paper, or the x and y positive axis, where D2 minus and D3 minus, that's when D2 negative and D3 negative represents the underachievement, because we know that negative indicates the underachievement and positive indicates the overachievement. So D2 negative and D3 negative represent the underachievement of sales volume for products A and B respectively. Since the sales target goals are given as I mentioned in the equation, since the sales target goals are given as the maximum possible sales volume, therefore D2 positive and D3 positive are not included in the sales target constants. The solution of the problem can be found by a simple examination of the problem. Very simple, because if we avoid D1 and negative and D1 positive, in the previous example, we get X1 value. If X2 is 0, then X1 is 7. If X1 is 0, then you get X2 is different value. So here also, the solution of the problem can be found by simple examination of the problem. If X1 equal to 5 and X2 equal to 4, then all targets will be achieved. Thus, D1 negative, D1 positive, D2 negative, D3 negative are all 0, are all satisfied 0. If D1 negative equal to D1 positive equal to D2 negative equal to D3 negative equal to 0, then what happened? X1 equal to 5 and X2 equal to 4, means it target the achieved goal. So there are so many steps. There are so many steps how to formulate the goal programming model. The first step is identify the goal. What I am doing in my example, in example 1 and example 2, I have explained in these steps. Identify the goals and constraints based on the availability of resources or constraints that may restrict achievement of the goals, that means target. Determine the second step, determine the priority to be associated with each goal in such a way that goals with priority level P1 are most important, thus the goals with priority P2 are next most important, and so on. In goal programming, all the goals, all the objectives are sequentially arranged as per the priority for the execution. For example, suppose we try to maximize the profit. At that time, the managers must focus or greater emphasis on social responsibility, social contribution, public relations, industrial and labor relations, etc. Such goals are sought because of outside pressure or voluntary management decisions non-economic goals exist and are gaining greater significance. That is actually the goal programming. We see management has multiple conflicting objectives to achieve in the present day or in the business scenario. This implies that decision criteria should be multidimensional and the decision involves multiple goals. In this context, goal programming assumes greater importance as a powerful quantitative techniques capable of handling multiple decision criteria. So in the second step that is mentioned here, determine the priority to be associated with the each goal in such a way that the goals with priority level P1 are most important, thus the priority P2 are the next most important and so on. Then the third step is very important, define decision variable. The fourth point is one, formulate the constraints in the same manner as formulated in the LPP model or LPP programming model. So in LPP what happened? When in a problem we are trying to solve the LPP, first we formulate the LPP, then we implement the graphical method or simplest method to solve or to find the optimal solution. But there is only one objective functions. That objective function may be minimized or may be maximized. That is mentioned here. Here we use the same process of LPP model to formulate the constraints. Then the fifth step is for each constraints, develop a equation by adding the deviational variable. In the earlier, we know that the deviational variable means di negative and di positive. The I stands, that means the index, that may be I equal to 1 to n. So d1, d2, d3 in this way as per the requirement of the constraints. The sixth step is write the objective functions in terms of minimizing a prioritized functions of the deviational variable. So these are the 6 steps how to formulate the goal formulations. In other words, I can explain how to formulate the goal programming. The goal programming model, formation of goal programming problems, with a relatively simple example. The steps we have taken in the model formulation can be briefly summarized as follows. Number 1, define variable and constants. The first step is model formation is the definition of choice variable and the right hand side constants. The right hand side constants may be either available resources or specified goal level. It required a careful analysis of the problem in order to identify all relevant variables that have some effect on the set of goals stated by the decision makers. The second step is formulate constraints. Formulate constraints through an analysis of the relationship among choice variable and their relationship to the goal. A set of constraints should be formulated. A constraint may be either a system constraint that defines the relationship between choice variable and the goals. It should be remembered that if there is no deviational variable to minimize in order to achieve a certain goal, a new constraint must be created. Also, if further refinement of goals and priorities is required, it may be facilitated by decomposing certain deviational variables. Third one, develop the objective functions. Through the analysis of decision makers, goal structure, the objective function must be developed first. So that is mentioned here. I am writing the objective function in terms of minimizing the priority functions of the deviational variable. Develop first, the primitive priority factors should be assigned to certain deviational variable that are relevant to goal attainment. That is the objective of the goal programming. Second, if necessary different weight must be assigned to deviational variable at the same priority level, it is imperative that goal at the same priority level must be executed. So these are the steps I have explained how to formulate the goal programming. Again, I am repeat here. Goal programming is a mathematical programming model. It's a special case of mathematical programming model, just like LPP. In LPP, what happens? There is only one objective function. But in goal programming, there are multiple objective functions. So we can use the deviational variables to solve the goal programming. So same process in goal programming also we used the graphical method or simplest method to solve the goal programming. So I'm explaining here. I'm not drawing the graph, but I'm explaining the steps, the graphical method to solve the goal programming. The steps are graph all the system constraints, thus not involving deviational variables, and identify the feasible solution space. If no system constraint exists, then the feasible solution space or region is the first quadrant. If no feasible solution space exists, there is no solution to the problem. The second step is graph the straight lines corresponding to the goal constraints, labeling the deviational variables. So again, I am explaining here. In LPP, linear programming problem, we solve the LPP problems by using graphical method. What are the steps in the graphical method? First, all the inequalities equations is converted as equality equations. Let us consider, suppose I am writing your maximize z equal to x1 plus x2. Maximize z equal to x1 plus x2. And the constant, subject to constants, there are two equations. 2x1 plus x2 less than equal to 5. And second constant is x1 plus 3x2 less than equal to 6. So there are two constants and subject to conditions what? x1, x2 greater than equal to 0. So this is LPP model. In LPP model, what are the first step? What are we doing in the graphical method? We convert the equation, inequality equation into equality equation. Then by keeping x2 0, you get x1, or there are two variables, no? If there are two variables, we solve it directly to find the intersection point between two lines, because a equation is there 2x1 plus x2 less than equal to 5. If you are converting into actually in the equality condition, that is equal to 5, then if you put x2 equal to 0, you get x1. So one point you get, that is x1 value 0. Similarly, if you put that is x1 equal to 0, we get the x2 value, that is 2 points. Because to draw a straight line, we need minimum 2 points. To draw a straight line, we need 2 points. So the first point we get x1 comma 0, and second one you get that is 0 and x2. By using this point, actual value of the x1, x2, you draw the points on a graph and you get a straight line. Similarly, if whenever you draw the lines in the first quadrant of the graph paper or in the axis, first quadrant of the axis, x-axis and y-axis, you get a feasible region, you get a feasible space or region. So in graph, all the system constraints, those not involving deviational variables, and identify the feasible solution space If no system constraint exists, then the feasible solution space or region is the first quadrant. If no feasible solution space exists, there is no solution. If there is no feasible region, then there is no solution to that problem. That is the first condition. Second one is your graph the straight lines corresponding to the goal constraints, labeling the deviational variables. The third step is that within the feasible solution space identified in step 1, determine the points the best satisfy the highest priority goal. That is very important in the graphical method to solve the goal programming. The fourth point is what? Sequentially consider the remaining goal and the point that satisfy them to the greatest extent possible. Make sure that a lower priority goal is not achieved by reducing the degree of achievement of the higher priority goal. And so these are the 4 steps to solve the goal programming by graphical method. Now I'm explaining in the previous example. In example 1, what I'm writing here, if you put x2 0, you get x1 7. That is 1 point. If you put x1 0, you get x2 14. The straight line is exactly the isopropit function line. Isopropit function line means all the values on that line must satisfy the objectives of the goal programming. That is, the total profit is rupees 700. Then various application areas of goal programming. So before we go into the application area of goal programming, so again I am explaining here. So goal programming concept is used in various organizations, and in particular in marketing, it is applicable for media planning and product mix. In finance, it is applicable for portfolio selection, capital budgeting, and financial planning. In production, it is applicable to aggregate production planning and scheduling. And in academic field, the goal programming is useful for faculty teaching schedule and admission planning. And in HRD, human resource development, it is applicable for manpower planning. And in general, public system, transportation system, and medical care system. So these are the different application area of goal programming. The formulation of goal programming model with its steps is very important, and it is used in different areas, that is known as marketing, finance, production, academic field, and HRD and public system, to find the best optimal solution. The application of goal programming for managerial decision analysis forces the decision maker to think of goals and constraints in terms of their importance to the organization. It may be mentioned in the passing that the limitations of linear programming technique in terms of assumptions, namely additivity, divisibility, deterministic, are attributes the goal programming also. Goal programming can be applied to almost unlimited managerial decision area. So that's why I am writing here. In the marketing, it is used for media planning and product mix. In finance, similarly, it is used for portfolio selection, capital budgeting, and financial planning. So capital budgeting, one example here, actually we can plan with different goals, different objectives we can take for profit maximization. In our financial planning also, in power production also to aggregate production planning and scheduling. In academic field also, faculty teaching schedule and admission planning. So there are different areas we can use this goal programming to achieve our target. Let us consider one more example. The manager of the only record shop in a town has a decision problem that involves multiple goals. The record shop employ 5 full-time and 4 part-time salesmen. The normal working hour per month for a full-time salesman and a part-time salesman are 160 hours and 80 hours respectively. According to the performance records of the salesman, the average sales have been 5 records per hour for full-time salesman and 2 records per hour for part-time salesmen. The average hourly wage rates are rupees 3 for full-time salesman and rupees 2 for the part-time salesman. Average profit from the sales of a record is rupees 1.50. In view of past sales record and increased enrollment at the local college, the manager feels that the sales goal for the next month should be rupees 5,500 records, since the shop is open 6 days a week. That is a strategy you can implement it for marketing. The shop is open 6 days a week. Overtime is often required for salesmen, not necessarily overtime, but extra hours for the part-time salesman. The manager believed that a good employer and employee relationship is an essential factor of business success. So to achieve the goal means always the goal of the organization is how to maximize, how to earn the money, how to maximize the profit with cost minimization. So there are other factors are related to maximize the profit. Therefore, the stable employment level with occasional overtime requirement is a better practice than the unstable employment level with no overtime. However, that overtime of more than 100 hours among the full-time salesmen should be avoided because of the declining sales effectiveness caused by fatigue. The manager has set the following goals. How to manager sales, how does manager fix the goals? That is, the first goal is to achieve the sales goal rupees 5,500 records for next month. That is a target. The second goal is to limit the overtime of full-time salesmen to 100 hours. That is the second goal. That is the second constraint. The third goal is to provide job security to salesmen. Job security to salesmen. If you provide full-time salesmen, then job security must be required. The manager feels that full utilization of employees' regular working hour is an important factor for good employer and employee relationship. However, we twice as concerned with the full utilization of full-time salesmen as with the full utilization of part-time salesmen. The last goal is to minimize the sum of overtime for both full-time and part-time salesmen. The manager desired to assign differential weightage to the minimization of overtime according to the net managerial profit ratio between the full-time and part-time salesmen. So this is a strategies in different organizations. When I am explained here in the example 1. Similarly, I am explained in this example. Achievement of the sales goal, which is set at rupees 5,500, is a function of total working hours of the full-time and part-time salesmen and their productivity sales per hour rates. So here also we write the equation that is similar to 100x1 plus x2 plus d1 negative minus d1 positive equal to 700. We can explain here 5x1 plus 2x2 plus d1 negative minus d1 positive equal to 5,500, where same process x1 total full-time salesman hours per month, x2 indicates total part-time salesman hours per month, d1 negative is underachievement of sales goal, and d1 positive equal to overachievement of the sales goal. And 5 indicates sales per hour for full-time salesman, that is mentioned in the example, and 2 sales per hour for part-time salesman. 5,500 rupees indicates sales goal per month. That is not your sales goal. Second one is your regular working hours. Salesman hours are determined by the regular working hours for each type of salesman, and the number of full-time and part-time salesmen employed. With the full-time salesman, the total regular working hours per month will be 5 into 160 equal to 800. For part-time salesman, the total salesman's hour per month will be 4 into 80 equal to 320. Thus, we have two constants, x1 plus d2 negative minus d2 positive equal to 800, and x2 plus d3 negative minus d3 positive equal to 320. In the second example here, we are not considering, because I am writing here. In the second example, I mentioned since the sales target goals are given as the maximum possible sales volume, therefore D2 plus and D3 plus are not included, but in this example, it is included. So D2 negative and D2 positive is included, where D2 negative indicates underutilization of the total regular full-time salesman hours per month, and D2 positive is overtime given to full-time salesman per month. D3 negative, underutilization of the total regular part-time salesman hours per month, and D3 positive, that is indicates overtime given to the part-time salesman per month. Then third point is your overtime. In this records of example, the manager second goal is to limit the overtime. Don't give the overtime maximum time, otherwise your organization gets different problem, financial problems. A full-time salesman to 100 hours. We do not have a deviational variable to minimize in order to achieve this goal in the above formulated constraints. Therefore, we must introduce a new constraint. The manager listed the minimization of overtime for full-time salesmen as a part of fourth goal is essential. He has to separate goals regarding the overtime work of full-time salesmen. The limit the overtime for full-time salesmen as a part of the fourth goal. In essence, the manager has to separate goals regarding the overtime work of full-time salesmen to the limit, that is D2 plus minus D2 minus D2 plus equal to 100. That is D2 positive is the actual overtime of the full-time salesman, and D2 negative is a difference between the actual overtime full-time salesman and these are 100 hours of overtime. Now, in general, the goal programming model can be formulated as Z equal to P1 D1 negative, P2 D2 positive plus 2 P3 D2 negative plus P3 D3 negative plus 3P4 D3 positive plus P4 D2 positive, subject to 5x1 plus 2x2 plus D1 negative minus D1 positive equal to 5500, x1 plus d2 negative minus d2 positive equal to 800, which is the second constant, and the third constant is that is the first equation, is the whole equation. Similarly, in our example, minimize z is the objective function subject to constant, that is the whole equation, 100 x1 plus x2 plus d1 negative minus d1 positive equal to 700 is the whole equation, and the constants are x1 plus d2 negative equal to 5 and x2 plus d3 negative equal to 4. All the divisional variables and x1 x2 variables are greater than 0. Here's the same thing, that is the x2 plus d3 negative minus d3 positive equal to 320, d3 positive d2 negative minus d2 positive equal to 100, and all the divisional variables must greater than equal to 0. So this is actually the goal programming, how to formulate. I'm explaining. So the managers formulate the goal programming and solve by using the simplest method or by using the graphical method. In the graphical method, what happens actually in the linear programming problem, you know that you draw the straight lines, find the feasible region, and where in which point in the after finding the feasible region, you can consider the points and put that point value in the objective function, and to get the result. To get the result means where it is maximize or minimize. If the question asks you maximize z, you get the maximized result of z, find the maximized z in which point. If the question mentioned that is minimize z, you have to find the point where the z value is minimized. So you put the value in the objective function and you just find the actually the maximize z or minimize z. But in goal programming, in the graphical method, there are 4 steps. That is the first you draw the lines one by one and find the feasible space or feasible region, and then within the feasible solution space, that is the third step I am mentioning here. Within the feasible solution space identified in step 1, determine the points the best satisfy the highest priority goal. And the fourth point I am writing in the fourth step, sequentially consider the remaining goals and the points that satisfy them to greatest extent possible. Make sure that a lower priority goal is achieved by reducing the degree of achievement of the higher priority goal. So first, higher priority goal must be achieved, then we go for the lower priority goal. So that is actually very important in your goal programming. The graphical method for solving the goal programming problem is quite similar to the graphical method of the linear programming, as I am telling you. In linear programming, method is used to maximize or minimize the objective function with one goal, where in goal programming, it is used to minimize the total deviation from a set of multiple goals. The deviation from the goal with the highest priority is minimized to the fullest extent possible before deviation from the next goal is minimized. The graphical method is explained. I'm explained here in the example. Here I mentioned this. In the example 1, in the above example, there are an infinite number of combinations because there is only one constant goal equations. If I am considering one goal equations, the number of combinations of x1 and x2, different x1 and x2 values can generate it, that will achieve the profit goal. That will achieve the profit goal means the points which are lying on the straight line on the straight line drawn by plotting the points, that is 07 and 014, sorry, 070 and 014, that is a straight line, and if you are naming it as AB, that means all the points x1 x2 value on the straight lines must satisfy the profit goal. The straight line, that's why it is called as a isopropit function line. This is a graphical solution, graphical method solutions. If there are numbers, for a second example, if you consider the second example, at that time x1 plus d2 negative equal to 5, x2 plus d3 negative equal to 4. So if you eliminate d2 value and d3 value, that means x1 equal to 5, and x2 equal to 4, and if you plot the straight lines, then there is another feasible region. In that feasible region, again we can follow the d2 minus, d3 minus, or d2 plus or d3 plus, means where the feasible region generate by using the constant equations. That is very important. So in this way you can solve by using graphical method. And similarly you can solve the goal programming by using the simplest method. In simplest method, similar to your LPP method, same process. Minimize the Z subject to constant and conditional equations are given, and we can solve by using the simplest method. In simplest method, we have to find the optimal solution. We can also using Excel solver to solve goal programming models. The main purpose of using solver as used in the corporate world is to find optimization. Many product development cycles are influenced by multiple factors, each of which can significantly change profit margin or product quality. If the relationship between these factors and a company's desired goals can be expressed mathematically, solver can quickly identify the value of these factors to meet the goals. Although this is a bit, it avoids the need to develop and use macros in Excel. You can solve by using Excel spreadsheet, the goal programming, which is beyond the scope of the process. So I'm summarized again here. What is actually learned in today's class? So first of all, you know what is actually goal programming and what is the difference between linear programming problem. So the definition of goal programming, you know about it. As the goal programming is an approach used for solving a multiple objective optimization problems. And the difference is that linear programming is only one goal, and that is maximization profit and minimization cost. But in goal programming, there are multiple goals with the deviational variables, and we try to minimize the deviational variables. That is the only difference between LPP and GP. And we learn how to formulate the goal programming with two suitable examples. The first example is actually a manufacturing firm produce two types of products A and B. That is the one example, best example, that is the single goal. So that's why I'm writing one goal equation: 100x1 plus x2 plus d1 negative minus d1 positive equal to 700. In example 2, that is not multiple goals are there. That's why I'm second two constants added here: x1 less than equal to 5 and x2 less than equal to 4. That is sales target goal and sales target goal I mentioned here. And the goal equation is 100x1 plus x2 plus d1 negative minus d1 positive equal to 700. Because that is mentioned in the question, The manager, in addition to the profit goal, rupees 700 in the example 1, also wants what to achieve? To achieve a sales volume for product A and product B close to 5 and 4 respectively. So here to another constant, to another objectives, another targets are actually is mentioned. That is sales target goal. Two sales target goals are there. That is x1 less than equal to 5, x2 less than equal to 4. So if you draw the lines, here also you can solve it. You can solve it by using the graphical method very easily. And the problem can be formulated. We also learn how to formulate the problems. That is minimize z equal to d1 negative plus d1 positive plus d2 negative plus d3 negative subject to constants. That is 100 x1 plus x2 plus d1 negative minus d1 positive equal to 700. And here d2 negative and d3 negative represent the underachievement of sales volume for product A and product B respectively. And the important point I am again explain, that is d2 positive and d3 positive are not included because the sales target goals mentioned in the question, that is maximum possible sales volume. If it is mentioned as minimum, then it is equal to add x1 plus d2 negative minus d2 positive equal to 5. It is equal to mention. The solution of the problem can be found by a simple examination of the problem, because it is simple example. That is, if d2 equal to 0 and d3 equal to 0, that is simply that is x1 equal to 5 and x2 equal to 4. Then all targets will be achieved. And if you plot these points, these straight lines in the graph paper, by using graphical method, you can solve it very easily. And we also learn the procedures to formulate the GP model. There are different steps, 6 steps are there. And also we learn the graphical method to solve the goal programming and what are the application areas of the goal programming. That is known as your goal programming can be used in different organizations, in marketing field, in finance area, in production area, in academic field, and HRD field, and public system. That is known as your application area of goal programming. Thank you. So the important questions may come. What is actually goal programming or defined goal programming? And what is the difference between LPP and goal programming? Explain with a suitable example. It may be the important questions. And the important questions is solve the goal programming by using graphical method or simplex method.